Bright Tuty. Every student matters.
Now let us look at these questions. In these two figures, DE is parallel to BC. So in both the figures, this line is parallel to this line. So in this DE is parallel to this, right? So this is B. Okay. Now we are given this AD and DB, AE, but EC is missing. Okay. So using BPT we will find the missing sides or missing lengths. So using BPT we can say if DE is parallel to BC, which is given, then we can say AD by DB is equal to AE by EC, and you can write by basic proportionality theorem. Right. Now these two are given, AD by DB 1.5 by 3, and it should be equal to AE by EC. AE is given as 1, EC we need to find out. So this is telling me that BEC will be equal to 2, right? Otherwise also, even if you look at this, if you look at these two portions, this is double of this. So this portion will be double of this. So this is going to be 2, right? Similarly, this method or this working you need to show in your examination. To understand this part here, I will not do the working. I will just comment directly. So now look at these two portions. In this also, DE is parallel to BC. So this ratio AD by DB will be equal to AE by EC, right? Once you have written this, now you look at this. This is 3 times of this. 18 3s are 54. So 1.8 into 3 is 5.4, right? So this side will be 1/3 of this. Why? Because this is 1/3 of this. So this will be 1/3 of this, right? So this will be 2.4. Otherwise, you can follow this process up to this. Now after this, you can write AD by DB, that is AD by 7.2 is equal to 1.8 by 5.4. Now this will give you 3 here. So AD is 7.2 by 3, that is 2.4, right? And the unit is centimeter. I hope you have understood this question. So let's move to the next one that we have here. E and F are points on the side PQ and PR respectively of a triangle PQR. So let's first of all make this triangle PQR. So this is P, this is Q, and this is R. E and F are points on PQ and PR respectively. So let this be E and let it be F. Now for each of the following cases, state whether EF is parallel to QR. So let us join these 2 points, and now we need to find out whether EF is parallel to QR. So we can say that EF is parallel to QR in which of the cases? If the ratio of these 2 portions is equal to the ratios of these 2 portions, right, the corresponding portions, or we studied about other things also, that the ratio of this and this complete side is equal to ratio of this and this complete side. Even then we can say that these 2 lines are parallel. So we will use the 3 results that we proved in BPT to see whether these lines are parallel or not. So let us look at the first point here. If PE is 3.9 and EQ is 3. So what is PE by EQ? It is 3.9 by 3, and PF by FR, it is 3.6 by 2.4. If these 2 ratios are same, only then we can say EF is parallel to QR. Look at these ratios. This ratio, the first one, this one is 1.3 by 1, right? Now this ratio here will give me, so this is 1.5 by 1. So these 2 ratios are not equal. Hence EF in the first case is not parallel to QR. So, in this case not parallel, right. Look at this second one, PE and QE. So, 4 by 4.5, PF and RF 8 by 9. So, these two are equal, right. 4 by 4.5 is equal to 8 by 9, because if you multiply this by 2, it will give you the same ratio. So, in this case these ratios are equal, PE by EQ is equal to PF by FR, hence EF is parallel to QR, right. Why? By converse of basic proportionality theorem. Okay. Look at the third one here. I will directly solve it here itself. PQ, that means this complete side, by PR, right. Let us divide PQ is 1.28, PR is 2.56. Now look at this, PE is 0.18, PE is equal to 0.18 and PF is equal to 0.36. So, PE by PQ, if I divide this PE by PQ, it will give me a ratio something like this, and if I divide PF by PR, it will give me this ratio. Now look at these two ratios, we do not have to solve any further, you just have a look at these. 0.18 is half of 0.36, 1.28 is half of 2.56. So, if I multiply this by 2 and this by 2, I will obtain the same ratio. So, these ratios are equal, PE by PQ is equal to PF by PR, hence line EF is parallel to QR, right. So, in this case it is parallel, and in the second case it was parallel, only in the first case it was not parallel, right. Now, in this question, now onwards I will do the questions in brief and you have to write all these steps, fair enough. So, it will save your time, okay. You will be able to do the questions very fast in the videos. So, LM is parallel to CB. So, this line is parallel to this line here. LN is parallel to CD. So, this line is parallel to this one. We need to prove that AM by MB, AM by AB equals AN by AD. This we need to prove, okay. So, by just looking at these two lines, that LM is parallel to CB, what we can say, that AM by MB is equal to AL by LC. This by this is equal to this by this, using BPT, right. Now, look at this triangle, this was in triangle ABC. Now, if I look in triangle ADC, line LN is parallel to CD. So, I can say AL by LC is equal to AN by ND. Now, if I compare this, let us say this is result 1, this is result 2. So, AL by LC, AL by LC. Now, if I compare these two, I can say AM by MB is equal to AN by ND, and this is what we wanted to prove. Okay. So, this was a simple application of Thales theorem. In this, DE is parallel to AC. So, these two lines are parallel. Okay. So, if this is given, I can obtain a result from it. What result can I obtain from it? That if these two lines are parallel, then I can say BD by AD is equal to BE by EC by BPT. This is one result that I have got using only this. Now I will use this DF is parallel to AE. So this DF is parallel to AE. Okay. Now these two lines are parallel, hence I can say that BD by AD is equal to, I am using these two lines this time, right? It is equal to BF by FE. Okay. So these are the results that I got from these two. Okay. Now I can compare result 1 and result 2 and prove the result that we wanted to prove. So if I compare these, the left hand side is equal, so the right hand side BE by EC will be equal to BF by FE. BF by FE equal to BE by EC, hence proved, right? So this is how we will go about these questions. You just keep on writing all these steps carefully, that what is given, let us say this is given, so this will give me this result, so let it be result number 1, and then this is given, so by basic proportionality theorem this is result number 2, right? You write all these steps and you will get full marks. Now in this question also DE is parallel to OQ. So what is DE? This is DE and it is parallel to OQ. Okay. So what does it tell me? That if these two lines are parallel, then in triangle PQO I can say PE by EQ is equal to PD by DO. Let it be my result number 1. So using this, DF is parallel to OR. So this is DF and it is parallel to OR. So in triangle POR, what I can say, PD by DO is equal to PF by FR. So PF by FR. Let it be my result number 2. So these two results I have got from these two information. Okay. Now if I compare these two, this is equal to this. Why? Because this is equal to this. So if I compare these two, PE by EQ is equal to PF by FR. So PE by EQ is equal to PF by FR. Now in triangle PQR, by converse of BPT, you can say that EF is parallel to QR, right? Why? Because these ratios are equal. So the converse of BPT tells me that this side is parallel to this side. All right. Okay. Let us look at this one. These figures might seem complex some of the times, but the questions are very simple. Okay. If you allow me to not tell you these steps, not write these steps, I can tell you these questions in 15 seconds. Okay. Look at this one. A, B and C are points on OP, OQ and OR respectively, right, such that AB is parallel to PQ. So this line is parallel to PQ. So look in the triangle POQ. These lines are parallel. So OA by AP is equal to OB by BQ. Okay, this is result 1. Now second thing which is given is AC is parallel to PR. So AC is parallel to PR. Now in triangle POR, OA by AP is equal to OC by CR. OC by CR. This is my result number 2. So using these two information, I have got these two results. I can very well compare these results because the left hand side is equal. So OB by BQ is equal to OC by CR. How did I get this? By comparing or equating 1 and 2. Okay. Now look at this. In triangle OQR, OB by BQ is equal to OC by CR. So using converse of basic proportionality theorem, we can say BC is parallel to QR, hence proved. Right? We had to prove that BC is parallel to QR. Right? Now these questions are very simple. If you know from your class 9th the midpoint theorem, right? Now using Thales theorem, we need to prove that a line drawn through midpoint of one side of a triangle parallel to another side bisects the third side. What it wants us to prove is, let us say this is A, B, C and this is point D, okay, and point D is midpoint of AB. So AD is equal to DB, okay, through the midpoint of one side. So D is midpoint of AB, okay, and parallel to another side. So we will draw a line parallel to BC, okay. Now if I take it E, then I need to prove that E is midpoint of AC, that is AE is equal to EC. This is what I need to prove. What is given is that AD is equal to DB and DE is parallel to, let me write it for you, AD is equal to DB and DE is parallel to BC. This is the given information, right? So proof. Now using BPT, why? Because DE is parallel to BC, so we can use basic proportionality theorem. We can say AD by DB is equal to AE by EC, right? Now I don't have to go any further. I know that AD equal to DB, so I can cancel it. So I will have 1 on the left hand side, AE by EC on the right one, which will give me the result that I am looking for, that AE is equal to EC, hence E is the midpoint of AC. Okay. So this was one of the simplest application of basic proportionality theorem, right? The same result we proved in class 9th using geometry. Remember? If you don't remember it, then go back to the class 9th book and look at it. Otherwise also we have proved it using BPT. Now let us look at the next one. Using converse of Thales theorem, prove that the line joining midpoints of any two sides of the triangle is parallel to the third side. So in this one, if I write it mathematically, what is given is line joining the midpoints of any two sides. So D is midpoint of AB, this is given, and I am writing it mathematically that D is midpoint of AB and E is midpoint of AC, right? These two things are given and we need to prove that DE is parallel to BC. Okay. So how can we prove it to be parallel to this side? If we know that the ratios of these portions AD by DB is equal to AE by EC. So look at this, AD by DB is 1. Why? Because D bisects AB, right? Similarly, AE by EC is also 1 because E bisects AC. So, these two ratios are equal. AD by DB is equal to AE by EC, and if these ratios are equal, then by converse of BPT we can say that DE is parallel to BC, hence proved, right. The line joining the midpoints is parallel to the third side, right. Let us look at this question. This question is an important question. Okay, ABCD is a trapezium. So let's make a trapezium here. AB is parallel to DC. So A, B, C, D, and these are the parallel sides, and its diagonals intersect each other at the point O. So let us draw the diagonals BD and AC. Let us name this point as O. Now we need to show that AO divided by BO is equal to CO divided by DO. So let us not worry about this result and start the question. Now we are given two parallel sides here, right. So I want to draw a line here parallel to side AB. Let us name it as OM. Construction, draw OM parallel to AB, let us say. Now if OM is parallel to AB and AB is parallel to DC, so we can say OM is also parallel to DC and AB also. So I have written this result in one sentence. Okay, so this is the construction that I have made. Now I will use basic proportionality theorem, and keep in mind that we need to find this ratio AO by BO, right. Now in triangle ACD, MO is parallel to DC, which will give me the result AM by MD is equal to AO by OC by BPT. Fair enough. Another triangle that we will use here is, I have used triangle ACD, right, because this line is in two triangles, triangle ADC and another triangle ADB. Now look at triangle ADB. MO is parallel to AB. So this tells me that MD by MA is equal to DO by OB, again by BPT. So I have got two results, result 1, result 2. Can I compare these results? Let us look. This is AM by MD, this is MD by AM. So if I take the reciprocal of this, the reciprocal of this will be MA by MD equals OB by OD, right. Now I can compare this and this, comparing 1 and 3. Okay, so left hand side is already equal, so AO by OC will be equal to OB by OD. Now what is the result that we are looking for? AO by BO. So we can bring this here, right. So AO by BO is equal to, so this will go in the numerator on the right hand side, CO by, we can write this as DO. I have written it in symmetrical fashion, AO, BO, CO and DO. So AO by BO is equal to CO by DO, hence proved. So, what was the construction? We just drew this line here, OM parallel to AB, right. So, this was the only construction in this, and then after that we applied basic proportionality theorem. The diagonals of a quadrilateral ABCD intersect each other at point O such that AO by BO equal to CO by DO. So, this was the ratio that we had to prove in the previous question. This time this ratio is already given and we need to show that this quadrilateral is a trapezium. So, we need to prove that it is a trapezium. Let it be A, B, C and D. This is AC, this is BD, and they intersect at a point O. Okay. What is given this time is AO by BO is equal to CO by DO. We will do that little construction once again. Let us draw this line, let us name it M. Okay. This OM parallel to BA, construction OM parallel to BA, draw OM parallel to BA. Now, in the last question we said that OM is parallel to BA, hence it was parallel to CD also. In this question we cannot make such an argument, right, because this is what we need to prove, that AB is parallel to CD. If we can prove that two sides of a quadrilateral are parallel, then we can say it is a trapezium, right. So, if we prove that AB, so if we can prove that AB is parallel to BC, then we can say that this quadrilateral is a trapezium. So, after drawing this, after making this construction, now we can say this is the proof. OM is parallel to BA. So, triangle in triangle DBA, OM is parallel to BA. So, I can say using the basic proportionality theorem that DM by MA is equal to DO by BO. Okay. Another triangle, another result that I am going to use here is this one. Now, BO by DO, from this BO by DO is equal to AO by CO. So, this is equal to AO by CO, right. I am doing this in brief. DM by MA is equal to DO by BO. This one was using converse of BPT, right, and this is given already. So, if you manipulate this and bring it here, AO by CO is equal to BO by DO. So, BO by DO is equal to AO by CO, right. So, we can write it like this. This will be CO by AO, right, because BO by DO is AO by CO. So, BO, so DO, the reciprocal of this will be DO by BO and it will be equal to CO by AO, which is this result. Now, look at these two. DM by MA is equal to CO by AO. So, in triangle ADC, I can say DM by MA is equal to CO by AO, or I can say MA by DM is equal to AO by CO. MA by DM is equal to AO by CO. So, these ratios are equal, hence by converse of BPT we can say MO is parallel to DC. MO is parallel to DC, right. Now, we started with the assumption, or we constructed OM parallel to BA. Now we have proved that it is parallel to DC, so we can say AB is parallel to CD. Hence, quadrilateral ABCD is a trapezium. Right. So, this is how we will prove it using converse of PPT. Okay. So, I hope you have enjoyed this exercise here and you have understood about Thales theorem and utilities or the usages of Thales theorem. Right. Thank you.